Welcome everyone to the season 3 of It Depends podcast. I am honored to talk to a very exciting company. You've heard of big data. You may have heard of something called white data, but how about vast data? Vast as in the name of this company, which in 2023 and in December, they got Series E funding and now are valued over $9 billion. So they're $9.1 billion valuation. So joining me today are two people who I'm honored to call my friends. Jeff Denworth, he is a co-founder of Vast Data, and Colleen, who is the field CTO and head of strategy. Let's start with some introductions. Jeff, Colleen, thank you so much for coming to this podcast.
Thanks for having
Sanjeev, it's great to be on.
Amazing. So Jeff, if you don't mind, I'd love to start with you. Can you give us some introduction of your journey up to this point and what have you been up to?
Well, a lot of email and Slack today, so it's been a busy one. No, I'm co-founder of the company. My specialty really is on the go-to-market side, so I help in places like product management and sales and marketing. 20-year plus startup veteran, so I've been through a lot of different chapters, different companies that I've worked with, and I've been fortunate to work with some pretty amazing people, like Colleen.
Yes, Colleen.
Yeah.
From those days. Yeah.
Yeah. No, I've had a sort of a roundabout journey here. I've mostly been on the engineering side. But through that journey, I've done a lot of the go-to-market stuff in my spare time. And so now I'm field CTO here and head of strategy for our database. It's really exciting where we are at this company. It's a very exciting time to be here and to be working on this.
Very cool. Jeff, I'm going to start with you. What is Vast Data and what was the trigger for starting this company?
Okay, so the company was founded at the earliest days of 2015, about 10 days after OpenAI was founded. And in the early days, we had an idea that we could simplify the way customers manage their data, accelerate access to that data, and help them protect and govern that data at just incredible levels of scale. And so, so at the time, the pedigree of the managers here, a lot of them came from the storage space. And at the time, there was like a ton of companies that were in the market looking to basically apply NVMe infrastructure to accelerate storage. We looked at the market and said, well, nobody's really thinking about how to make flash cheaper. And if you can solve the capacity cost problem, then customers can consolidate their data centers down to a single tier. And that seemed to be really important as the world was starting to transform to these new modes of processing where you want to go back to your data over and over and over again. And so the Vast Data platform is basically founded on this idea that we can build a very universal storage system that doesn't just support the needs of new AI applications, but is an enterprise platform where customers can use it for all of their applications and all of their data. Single tier, very affordable, very simple. And then as time's gone on, what we really wanted to do was to build essentially a web scale computer, the first application of which is serving files and serving objects. But now we're bringing a lot more intelligence into the platform for things like value extraction so that customers can actually implement AI in the system itself.
When you started the company, were you thinking mainly on premises? Or was it always designed to be on premises, multi-cloud?
The original work that we did borrowed from a number of new technologies that you could only find in the market in the commodity space, in the component space. And so this is a system that uses a next generation storage protocol called NVMe over fabrics to basically interconnect all of the system's logic, which we implement in stateless containers, with a massive pool of very low cost QLC flash. And if I think about those different elements, containers were just starting to get up and running in the cloud space when we started. But there definitely was no fast networks that were commodity. and nor was there anything from a low-cost flash perspective. So when we started, we made the decision to start building a reference architecture that customers could deploy on premises. And now we're fortunate to have a number of other hardware partners that also kind of bring these technologies out to market. And during that time, the cloud vendors evolved. And we'd like to think that if they could start at the time we started, they'd be making a lot of the same decisions as us. And so you're starting to see very low-cost flash options and fast networks evolve in public clouds. And we're now starting to deploy our software in those environments in a way that we could always do on premises since we've started.
So is VAST hardware or VAST data platform used in public clouds? Like are the hyperscalers using VAST or there are these new second tier cloud providers?
Well, I'm not sure they would like to be called second tier, Sanjeev.
Yes.
They think of themselves as
not hyperscalers, but
well, some of them are spending some real money. You're talking about billions of dollars of capital that's being deployed. So I think the simple answer to your question, which is, are you selling through Amazon, Google, Microsoft, companies like this? Not yet. They haven't yet chosen to take a vast first-party service out to market. You can take our software and you can deploy it in virtual machines in their environments, but I don't think that's the question that you were really asking. Now, secondarily, there are, as you alluded to, there's a whole new class of next generation cloud platforms that are emerging that are really specialized in things like GPUs and at scale model training, model inference. And we've been really fortunate here that these organizations, they don't have the kind of the legacy and the kind of the infrastructure decisions that were made 5-10 years ago that they have to reconcile against. And so these organizations are very frequently choosing VAST as the platform that they take their services out to market. And so, like I said, they're spending real money. Examples of ones that we can talk about are CoreWeave, which is an extremely large GPU cloud partner that we've been fortunate to work with. Another one is Core42. These guys are based out of the Middle East, but they're now starting to build a global organization. We have Lambda Labs, which is another great partner, and there's a variety of other kind of cloud, or I should say AI native clouds that are emerging that we're building out right now.
I love that. AI. So we've gone from cloud native to being AI native. I'm itching to find out about your strategy from both of you. But Jeff, before we go there, what is your North Star?
Oh, this one's really weird. So we actually took the covers. It's funny when I look at the seed round funding deck that we wrote. Oh gosh, it's like more than 8 years ago now. There was all sorts of weird stuff going on there. There was like Thomas Carlyle quotes and a number of other things. But at the end, there was just a picture of a brain, and it said, can we build a thinking machine? And actually, what we're trying to build is a system that can collect all the world's knowledge and essentially aggregate it around all the world's processors, and over time build the toolkits and the mechanisms for deep learning such that we hope that these machines ultimately are responsible for finding discoveries that humans haven't been able to as they've evolved. And so what we see is like an exponential curve of discovery that's about to happen thanks to AI. And we want to build the infrastructure for that next wave of scientific and mathematics and even arts, kind of societal advancement.
That is great. So, Colleen, thank you for your patience.
That's okay.
The same question.
I'm used to hearing Jeff talk. It's fine.
What's your North Star?
My North Star. I mean, my snarky answer is Polaris. But my non-snarky answer.
United Airlines Polaris Lounge.
Oh yeah, that's pretty nice. No, I meant the actual star. But no, I think for me, the common thread through all of my career moves, and which have culminated in me being here at VAST, is really about accelerating time to insight, right? And what that boils down to has changed over time, right? Like that's a very simplistic view, but it's really all about streamlining the value path of data. And the use cases have changed and that path has changed. It's become more complex. I mean, 40 years ago, everything was a monolith, then it became composable to a fault. And now we're sort of, finding a happy medium between those two things. And so for me, it's all about really taking data and making something of it. And I do think that we haven't been able to activate most of the data that we have. 95% of the data is unstructured, right? And some companies can focus on that, but a lot of companies, they've got their structured data under control. They have a BI solution, but when it comes to true data maturity, you really want to be able to activate all of your data. And doing that at the scale that we're at now and the scale that we're going to be in 5 years, I mean, that's an incredibly cool problem to solve. And so I think the reason I came to VAST is because I think VAST is thinking about it the right way by saying, well, let's not just accept the paradigms of cloud infrastructure, right? Or of the usual on-prem infrastructure. Let's rethink everything, right? Let's go back to the beginning and go back to the drawing board and say, okay, data is being produced, then what, right? And looking at that entire pipeline, not just small pieces of it. And doing things like thinking about the ROI of data and decreasing the TCO and increasing the value of that data over time. And I think it's just really cool the way we're doing it.
And so I want to take it to the next level because I want to
Yeah.
understand how are you doing this? So you're new in this role, you're leading the strategy for vast data. What is the next step that you have to do to rethink, reduce the
Yeah.
time to insights? How do you go about that?
Yeah. Well, I think it's really, as Jeff said, it's about the scale that we're thinking about. Like AI is a completely different ballgame, right? Like the data scales we're talking about compared to BI and structured data, it's just a massive change in scales. And so you have to rethink everything from storage and compute on up. And it's not just switching vendors, it's an entire rethink of the strategy. And so you have to really be able to accommodate that scale. But when you talk about those scales, if you're talking about running AI and running generative AI on something, one GPU, it might take 300 years to run ChatGPT's algorithm. So, you've got to start thinking about performance in a different way too, and really like different kinds of chips and different kinds of infrastructure at every level and different networks and different protocols and things. And then you still have the same old problems you've had this whole time with curation of data. You still need to handle your structured data. And so, I think the way VAST has a holistic approach, it's still composable and we still play along with all the other market players in the market, but we're composable, but also holistic in that we can focus on the entire stack and really improve everywhere along that infrastructure. And I think that's really important. And so really taking a look at what's
Yeah.
best for structured data at the scales we're talking about, but also unstructured data and having a holistic ecosystem for both of those.
Yeah, I came across a paper today on Vast Data's website on this parallelism of training models, and I was quite amazed to find out when I was reading that if you had only one NVIDIA A100 GPU and you wanted to train GPT-3, it would take 300 years.
Yeah, so parallelism, super important.
Wow.
Super important.
So
Yeah.
Jeff,
But if you have two of them, it only takes 150 years. Think about that.
Yeah. But no, I'm just wondering, like, if you have two, because it shouldn't be linear, right? So how how does that curve start coming down?
Well, at the computational level, if you think about these machines, they're basically just doing like massive matrix multiplication on systems that cost, $500 billion, sometimes more in terms of the dollar investments that these customers are making on the systems. And they need super, super fast networks to interconnect all these processors so that they can basically align themselves to different time steps in the job. And then actually from the perspective of the large language models, if you're dealing with text, they're actually pretty easy to ultimately feed. And the blog that Colleen wrote with Kartik was really around, okay, so if I'm running a job, actually one of my favorite stories is we have this customer who is building a large language model engine. And I said, okay, well, how long is the model going to take to train? And they said, well, it'll take a year. So somebody just like, pushes a button and then goes and grabs an extremely long cup of coffee. And the professor was like, yeah.
Yeah, I'm just thinking.
So I said, I hope you're checkpointing this operation. So a checkpoint is basically taking like system state down to storage for some period of time, so that if something fails, you can recover from a point in time in the job and don't have to start to restart the job all over again. And that's actually a reasonably performance intensive workload, in that you have to write data, and then when something fails, you have to read back to all the machines in parallel, and that's a really complicated task. And so that's kind of like text-based and kind of free text large language models. Then you move to things like video and imagery with computer vision, and that's where you have this exponential curve of data ingestion that has to happen to train these machines.
Yeah. And that the blog gets into this is what happens when you have two physics nerds writing a blog, right? Like we start to be like, here's the math behind it.
Yeah.
But Kartik and I did we didn't do the calculations. There's an academic paper we reference that does a lot of the calculations. But what's interesting is that it turns out that because of parallelism, you don't actually have to checkpoint absolutely every GPU in the system, right? Like you can take advantage of the parallelism. And what that does is, you've got data parallelism, you've got model parallelism, and you've got pipeline parallelism. And so if you combine those three, you sort of got three dimensions that you're thinking about, and each GPU is only operating on a portion of that. And so the way it works out is that you actually, when you checkpoint, you're checkpointing a portion of the system. And so you can actually get that down to something much more reasonable. You don't have to like wait for the entire model to be read out, because the model itself is huge. Yeah. And you don't have to wait for all of the data, because the data is parallel and it's on disk. But the other piece of that that's really interesting is it's not only about recoverability, it's about repeatability, right? Like we're starting to think about AI security and AI repeatability, and the idea of being able to like go back and prove where a result came from in AI is really interesting. So yeah, it's all fascinating if you get down.
It's fascinating. So you have a universal storage layer. So in the cloud, we have separated compute and store. Now, I may have GPUs where I'm training or running models, but I may have CPUs. I may have like NVIDIA and inferential, but let's say a commodity. I have NVIDIA, I have Intel, I have AMD. Can I have a mix of types of compute, CPUs and GPUs on the same storage layer?
Of course, we would expect that. Most people do data prep using conventional x86-based systems, or ARM-based systems, and oftentimes they're using toolkits like Spark in order to do this data preparation. And that's the first place that things like large-scale databases and data warehouses come in, because all these pieces of data have to be aggregated, they need to be labeled, and that context needs to live in a place that ultimately is interrogatable. And then the data flows into a place that you ultimately want to train on it. And here you find yourself in the file system universe, oftentimes talking to an AI processor, a GPU. And here, that stuff needs to be very, very high performance. So NVIDIA only has a select number of companies that they work with on their SuperPod reference architecture, which is like the biggest of the big systems that NVIDIA builds. And you should expect that these are going to coexist in a modern pipeline. And then when you go and run inference applications, like there's one running on my laptop right now. I could put a mustache on myself if I wanted to, thanks to some computer vision. And so pretty much every modern processor is used at some point in either the training or the inference process.
And different steps of those processes are just vastly, sorry, I always say vastly and then I stop myself. They're just vastly different scales. So like you start out with, tens of petabytes, and then you're gonna whittle that down to your actual data set that you're running training on. But as Jeff said, there's going to be metadata about all of your data as well. And that might be structured data in a database. And so you have all these different scales. And so there's different compute scales as well.
I see. Who is the buyer what's your ideal customer profile?
Do you want to buy one?
I would like a couple of GPUs, why not? Yeah, yeah.
I think we have two, and they're actually at different points in the kind of the generative AI maturity curve. A lot of these big clouds that we work with, or a lot of the really big technology companies that we work with, they're more focused on building things like foundational models. So, not that they're a customer of ours necessarily, but just take like OpenAI, GPT-3, GPT-4 are foundational models. And so that requires a ton of infrastructure, a ton of data that needs to be heavily curated and prepped and then put into these big supercomputers. And then the question becomes, well, once you have these things, are they actually informed on, let's say, an enterprise's business and the learnings that have been accumulated over that organization's history? The answer is almost always no. They're trained on things like Reddit data sets and what have you. And so there's a second step that has to happen when organizations take responsibility for fine-tuning these domain-specific models that are relevant for their businesses. And we actually end up selling to both. We work with some of the biggest model builders in the world, and then that same code then gets sent down the street to Fortune 1000 organizations that take these models, refine them a little bit more against their data sets, which equally need to be available at for fast access. And then they have something that's relevant for their business.
That's great. Colleen, anything you want to add?
Yeah, I mean, we've definitely found ourselves talking to a spectrum of people. It's really fun going to these conferences because you talk to people at reInvent or Big Data London, and you talk to people who are data engineers, you talk to software engineers, infrastructure folks, and CDOs, CIOs. And so I do think that our story really resonates with a lot of different personalities because we do get back to the story of what are you doing with your data? Right. And some people care about the storage much more than they care about the application. And then some people don't know anything about storage and they only care about the application. And then there's sort of the strategic folks who are looking at the entire pipeline. And I think that we really, like I said, we have that end-to-end view in a lot of ways where, between us and our partners, we really do cover the entire ecosystem. And so I've enjoyed seeing how the story resonates with different people. But yeah, I mean, for who we talk to day to day, I've talked to infrastructure people and data engineers, CDOs, CIOs. It's pretty cool.
Since there's so many personas involved,
yeah,
can we dig deeper into what are the building blocks of vast data platform?
You want to take that? You want me to do?
Well, now I'm like, okay, we got a newbie here. Let's no, I'm not going to put Colleen on the spot. So okay, so I personally like to think that it's just one unified system.
Yeah.
That you can think of as first and foremost, what we have are a new set of data structures that are used to create the data layer.
Okay.
And so think about this as rich metadata that sits on top of a very, very low cost, kind of born in the era of flash data store, that can receive data through a number of different modalities or protocols. So we can store files using enterprise access endpoints like NFS or SMB, and we even have some accelerations for NFS that are more appropriate for things like supercomputers and these AI systems. So RDMA using NFS or GPU direct storage using NFS. And then the system can also read and write data via object protocols, S3. And so those are like the unstructured data elements of the system. And then you have the structured data elements of the system where customers can write into our system using standard SQL. You can ETL data via Parquet into the system. And in this case, as opposed to storing data as like raw payloads that you can see through unstructured data protocols, we're actually converting this data into a tabular data form. The table form that is designed to transact in rows, but read using a very, very flash optimized columnar data format that gives you the best possible query performance that you can imagine. And so this data layer becomes kind of enhanced with all sorts of different data management tools that you get with the system. Everything that you would expect from a standard enterprise data store, things like encryption, data reduction, as well as things like auditability and multi-tenancy and zero trust principles. And then on top of that, Then we start to, over the next 2 quarters, we'll start to introduce the second aspect of the system. If you think about it as just like a giant data center scale computer, you've got the data layer, and that gets coupled with the computational layer next. So think about this as like we call it the vast data engine. And what you have here is a encapsulated container that allows you to do things like bring your own functions into the system in the form of lambdas. You can run containers in the system in an orchestrated manner. You can have an eventing system in this vast data engine, and all of it works together with the data to create like a data flow computer. The last element of this is it's a system that is designed to kind of federate all the different places that customers want to compute. And so this is the final, let's call it building blocks, Sanjeev, where the vast data space is essentially our global data management system that stitches together all the different independent clusters that you might have in your environment, the cloud, on your on-premises data center in a colo, or maybe it's some edge data center, into one coherent namespace that's designed for both structured and unstructured data.
Very interesting. So let's take an example. If I have Snowflake in my organization, and I'm using Snowflake to run, let's say, reports and dashboards, but let's be fair, I also have Databricks where I'm doing some machine learning. And under what circumstances should I bring in VAST, and how would VAST work with these two examples?
So I think the question is, what are you ultimately doing with the data? And if it is machine learning, dashboards, BI, that kind of thing, it's largely structured data. And I'm curious where the unstructured data is coming in, right? And so typically what we see is that folks are starting to think about activating their unstructured data when they're having these conversations with us. And the struggle with a lot of these cloud-based data warehouse vendors, it doesn't scale particularly well, and the cost is exponential. And the pipelining of data, like to move it around, to replicate it, and the latency inherent in systems like that, let alone the resiliency, can be really challenging. And I mean, I've used Snowflake, I've used Redshift, I've used all of these, some of them are fantastic, but I do think that it's a question of scaling. And so sort of that holy trinity of scale, processing, performance, and cost efficiency is really what we're going after. And so it's hard to get two of those, let alone all three. And so VAST is really offering all three at the scale that you need to handle unstructured data as well. So, when you're doing BI and dashboards, that's purely a structured data use case.
Yes.
But it's when you start to try to answer the questions about unstructured data and AI and larger scales that you really are going to struggle in those other environments.
So if I may paraphrase, so what you're saying is that structured data is commodity. We've been doing it for a long time. It's the unstructured data, which is 95% of,
Like that, yeah.
which is untapped. And we're still learning how to analyze it at low cost, highly reliable.
Well, I think deep learning is the trigger, right? If you think about unstructured data, it's been sitting in our archives forever because it's not been understandable, because there hasn't been the algorithms in the form of neural networks, nor has there been the processors that are now come in the form of GPUs that can make sense of this. And so if you think about a modern business is taking all the different data streams that it can acquire and correlating it and analyzing it to the greatest degree possible. My thesis is that deep learning in particular is growing the big data TAM by a factor of 20, because now we have this rich data type that is ripe for processing and interrogating and re-interrogating. As the models get smarter, you want to continue to go back to that data more and more to learn things that you couldn't learn previously.
We've talked about the use cases, Jeff, like training models, even fine-tuning. What are some use cases that we haven't talked about, or some that surprised you because your customers bought vast data platform, but then they started using it in new innovative manner that was that expanded its usage? Are there any such use cases?
Yeah, I think we tend to get surprised all the time. So we've we didn't really talk much about the business story, but you mentioned the valuation earlier, it's 9 billion. That doesn't come without a pretty broad amount of customer adoption. And here, we're many hundreds of customers around the world, tens of exabytes that have been shipped into the market. And we really do have a diverse set of workloads that we go after: financial services, life sciences, media, government, and defense, and a number of different other markets. I think the story that I kind of like best, because it to me represents what I think will be happening to almost everybody around the world, is one of a story that was told by Pixar. So Pixar, obviously a very famous animation studio that creates some really great movies. Pixar started working with us like 4 years ago, before ChatGPT was a thing, before anybody was really even doing AI outside of the large major technology companies. And they ended up using our system for essentially their render farms needed much more scalable and affordable infrastructure for high performance data access. And over time, Pixar has basically put all of their pipelines on VAST, and that's been just a great relationship we had with them. But Eric, the manager there, he said, a few months ago, I was sitting just watching some stuff fly around the network in a very anomalous way. I didn't really understand what this person was trying to do. So I call him up and I say, "Hey, who are you and what are you doing?" He says, "Well, I'm a researcher working for Disney, and I am basically figuring out how to apply the Pixar style of lighting across all the movies using deep learning and artificial intelligence." So, okay, well, how can I help? And he said, "Well, your data infrastructure is really slow." And Eric says, "Well, that's just because I put some arbitrary bottlenecks up so that nobody can overrun the systems. What if I give you a backdoor and helped you go and train on this data in a much more performance efficient fashion?" I was like, "Oh, that would be great." And so at that moment, everybody in the whole team gave themselves like a big pat on the back and like, okay, we've modernized our infrastructure for AI. And the cool thing was, what we didn't know is if it was ever going to happen, or if how it would happen. And then even our customers are getting surprised by these new kind of researchers and new application teams coming in saying, we need to really start understanding this data in a new and interesting way. So that seems to be a common theme across our existing customers. And then our new ones, we're getting calls from a lot of places like big banks and healthcare systems and government customers, where they're just saying, okay, this is the first use case we need to start on. I know, by the way, we need to start yesterday.
That's great. Colleen, I know you're relatively new, but what has been your big revelation from customers?
I think the breadth of use cases is really exciting. Like the fact that we are crossing so many verticals, and we don't talk to folks who don't have a huge quantity of data, but it's been exciting seeing how much data is really going into these systems. As Jeff said, there's tens of exabytes out there in vast systems, and that's just incredible to me. And I see these, I've talked to the sales folks, and I see deals coming in, and I'm like, wow, that is an absolutely enormous quantity of data, and it's really cool seeing what people are doing with it. And I think there's an untapped market out there for this, and I'm just really excited to be part of it, honestly. The Pixar story is one of my favorite. I also like the Zoom story.
So what is the Zoom story?
I'll probably let Jeff tell it because he tells it on the website. If you look at the website, it's on there.
Because Zoom went from 30 million to 300 million customers pretty much overnight when COVID hit.
Yeah. We're on Zoom right now.
Yeah, and we're recording it on Zoom. Yeah.
So I think the thing to think about is how do you characterize Zoom's business, right? Is it a communications tool, or is it a business tool? And if it's a business tool that's aggregating a ton of unstructured data, then the question becomes, what's the value for customers with Zoom in an era where this data is understandable? And so my general thinking is, if you think about Salesforce, Salesforce has the market cornered when you have a salesperson that can go and type a bunch of stuff into a keyboard and tell Salesforce exactly what's happening, right? And the forms of analytics required to do that are not as difficult as the type of analytics required for computer vision and natural language processing and large language processing that you have with unstructured data, right? We're not typing anything into our laptops right now. Yet there's a ton of information that's being captured. And so if you think about the last mile for most businesses, we all spend all of our days on Zoom. If I can take that data, if I can assimilate it, and I can, go start to mine that data in new and interesting ways, not just from like, can I transcribe a video, but can I actually understand the nuances of actions and what people are looking at and their body language? Can I tell if they're lying or not? Like, these are crazy things that AI finally allows us to do. And so my general thinking is Zoom is one of the most unrealized, kind of great businesses in the BI tool space and in the CRM space, because they're sitting on all this information. So we work with the Zoom AI team to help them train all of their new models and all of their new applications against the data that they're accumulating from all of these different encounters, so that they can improve their services out to customers over time.
When you talk about so much data, with all this data comes a lot of responsibility. What is your strategy, your approach to govern all this data because of GDPR and all of these things? How do you make sure that people won't just misuse or inadvertently take sensitive data out of a vast data platform and use it?
Well, I think that's a really interesting question in 2024. And in particular, I think about this idea of foundational model creation and domain-specific model training, right? And if you think about both of these cases, the data sets used to go and train these models are by far the most valuable part of the artificial intelligence implementation effort. And so that means that you have this like piece of gold sitting in your data center. And if that thing gets lost, or if it gets crypto locked or something like that, your whole AI efforts are, pardon my French, up a certain creek. And so the first question becomes, if I'm big in AI, everybody's waking up now this year and realizing, oh my gosh, I really need to think about data protection, like really simple things. But now you have concepts that are like familiar in the financial services space, like worm and retention. And the technologies that have been implemented there are now being applied to preserve language model data sets. You have things like ransomware protection that become critical, because that data set may be the only copy of a thing sitting next to $1 billion computer that a customer is running. And so the first part of it is like, let's make sure that we don't lose the data through hook or crook. And then the second thing becomes, well, how can we ensure security on this data and provenance on this data, right? So security comes in largely through the implementation of multi-tenancy tools and zero trust principles. And I think that's been a big lacking capability in the market. If you think about how infrastructure is being deployed for training, either you have like tools that were perfected in the supercomputing space for the last 20 years that are only usable by researchers and they don't have any features, or you have these old stodgy enterprise products that can't scale at all to the needs of the AI infrastructure of today. And we kind of sit in the middle of this kind of a Venn diagram that consists of very, very high performance infrastructure with tons of enterprise data management features that make it sensible to deploy this stuff with. Okay, so now we've got this platform that's really featureful. Where do you find it first and foremost? Like I said earlier, AI clouds. And these AI clouds require things like multi-tenancy. They require things like dedicated encryption per tenant with external key management support. All the things that you would expect to get in like a cloud native service from AWS or Microsoft or Google, but they have to be also appropriate for this new level of deep learning. And then finally, provenance and auditability comes in. And here we have a whole bunch of tools that customers can use to track every single data touch, every single data augmentation, and report that in real time, almost like a SIM out to the user communities that use our product.
Are you storing the metadata that is being generated in your own proprietary format, or using a database like relational, non-relational?
Well, so that's the interesting thing. Like, yes, we started in the unstructured data space, but that's only part of the problem, right? Because if deep learning is what allows you to derive structure from unstructured data, well, that information needs to live somewhere.
Yes.
And it needs to live and thrive in an environment that can keep pace with real-time data streams that are hitting the system from, millions of endpoints, but also the analytics requirements associated with understanding that data. And so for that reason, we invented our own next generation distributed database that we call the VAST database. It's an amazing name. We spent billions of dollars with McKinsey to figure that one out.
Yeah.
But actually, why do we call it a database? Well, if you go back like 40 years ago, you didn't have data lakes and data warehouses and event queues, and you didn't have data lakehouses or all this stuff. You just had database management systems that you could write to, you could query from. They weren't necessarily fast, and nobody had big data to challenge architectures. And we like that idea. One system that you can just use for data ingestion, data processing, and data preservation. And so if you can break all the trade-offs, then you don't need all this stuff. And so that's why we built this this database management system that you can think of as you can transact to it as fast as you could transact to like a Kafka event queue that could scale to thousands and thousands of machines, all completely on a linear fashion. You can query from it this tabular format, just like you would query from a high-performance enterprise data warehouse that was built from the ground up for NVMe flash, which, by the way, hasn't really ever existed until VAST. And then on top of it, it should scale and should be no more costly than what you expect from a data lake. And when you put it all together and you got something that's fast and cheap and scalable, it's just a database that you can use at exabyte scale proportions. And that becomes the metadata engine of this whole thing. We have customers using it for things like tables. You asked, if customers should use this as opposed to Snowflake or Databricks. Sometimes if you're building very large high-performance data warehouses, that makes sense. But the North Star that you asked about earlier, Sanjeev, is like, let's think about the coexistence of structured and unstructured data. You need that high-performance transactional data warehouse sitting right next to a file system, and they need to work together. That's what we built.
Yeah, by the way, thank you so much for that answer. I've been terrified of this thought that as we do more and more in unstructured world, we're going to have a yet another stack. I mean, we are already struggling with this modern data stack for structured data, and now we're going to have a separate stack, which may also splinter. So I love the story of unifying, integrating structured, unstructured, and then putting any kind of analytical engine on top. That analytical engine could be Starburst, Trino, it could be an LLM or an AI, So, but
even know about it. Yeah. And I think that's the key too, is that, you don't want to have, in a simplistic fashion, you can think about having 3 stacks, right? You have some operational transactional stack.
Right.
Then you're copying everything over to a BI stack, all your structured data. And then you need a third stack because now your board says do AI, whatever that means. And so you end up with 3 disparate stacks, and you have to have pipelines at every step of the way. Think about the latency, the data drift, the correctness issues, the resiliency, let alone the governance of that. I mean, that terrifies me. And so simplification here is only going to help. It's going to help in lower TCO, lower complexity, increase performance, increase scale. It's just it's gonna make everything more feasible.
Yeah, we are on the same page because we don't move data around because one team wants to use Spark, another one wants to use SQL, another one wants to use some API or do conversational or pandas, that is great. So we're coming towards the end of our show. We can talk forever, but I'm just curious, your Series E was just 100 million, Jeff?
I want to say it was 118, if my memory serves me.
What is the plan for raising that much money? What's on your roadmap?
the same thing that we do every day, which is we don't spend the money. So it's,
So why
you know, Vast is we're a bunch of cheap bastards, that's for sure. And, you know, if you think about it, we diluted the company by 1%, a little bit more than 1%, to show to the world that our valuation has grown by 2.5x at a time where, you know, we talk to other startups where if they can maintain their valuation, that's a good day. And so our stock is like completely correlated with NVIDIA's right now. We're working with a lot of the same customers in terms of the growth over the last 2 years. And the problem with being a private company is not everybody appreciates what's happening unless you kind of like hit the gong really hard. And so periodically we do that with these fundraising events, more to show the world that we're incrementing the business in the way that we kind of had always hoped to, and helping provide some credibility to what we're doing. And so the new investors that came in on the last round are some of the best investors in the world, like NEA and Fidelity, Bond and Drive Capital. So that's testament to the fact that we're really doing some amazing things. Before we go public, it's best you get. But the money sits in the bank. We managed to sit cash flow positive now for a number of years. And so it generates interest.
Yeah, which is, and also it's a testament to your ability to raise money in such a tight market. Yeah,
I think the testament comes from the customer adoption. That makes it easy to raise the money.
do you see in 2024 the IPO market will open up for tech stocks? I know it's got nothing to do with
So we get a lot of bankers talking to us all the time. I can say that, you know, everybody at the beginning of last year said the end of the year is probably going to be the time. And it's the beginning of a new year, and everybody's saying the end of the year is really going to happen. And so, you know, if I knew that, I wouldn't be here. I'd be, you know, on some sort of like 90th floor in some Wall Street building making $1 trillion bets.
Yeah. And I'll return those 2 GPUs, Colleen, and take some stock instead, you know. So yeah.
Understandable.
Yeah. So I want to end on a sort of interesting note. So I'm curious if you can tell us some non-technical stuff that you both do, your passion that the world doesn't know in general, but you like to do. So Colleen, can we start with you?
I mean, I'm super curious what Jeff is gonna say. I mean, I love to travel, so that's me. I also read like 2 or 3 books a week. That's my thing.
Wow.
Not all like high class, like Tolstoy or anything. A lot of trash too, but I do. I read a lot of.
I have to ask you, what's your favorite book? A few books that you would recommend to the.
Recently, I just finished Gravitas by Lisa Sun, which was fantastic. I read, what else did I read recently? The Lioness of Boston by Emily Hamilton. That was fantastic. A lot of nonfiction. I see a lot of stuff on TikTok, and then I'm like, I'm gonna go read a book about that. And so that's how I yeah, I read
very impressive. 2 to 3 books a week.
On average, probably 2, but yeah.
Phenomenal. All right, Jeff, how about you?
Well, I can't let Colleen win. I read 3 to 4 books a week. all Tolstoy, all the time, by the way. No, I'm Sanjeev. I'm the most boring person in the world. I just work all the time. Don't ask me this question.
I have had dinner with you, and I know that is not true.
Yeah.
So yeah.
It's true. But I was looking at my phone most of the time. I'm secretly typing messages.
Jeff is super fun.
Yeah.
I like to have fun at work.
When you are on the 90th floor penthouse in New York, then we will have a different discussion. So
we will.
Right now he's on the 11th floor, so
we'll need oxygen masks.
Yeah, that is true. The 90th floor in Dubai would be fine, you know.
Oh, we'll be on the top of the Burj Khalifa.
Yes, exactly. Yeah, that's where we'll have the public party, you know.
Man.
That'd be awesome. We'll get your face, you know, the big LED signs that you can create on the side of the building.
Yeah.
We'll call it the Sanjeev Tower.
I want to do the Mission Impossible one, like
Oh, yeah.
climb.
We'll get you one of
up,
those. We got you.
Okay,
No problem.
awesome. Well, on this note, you guys have been amazing. So much knowledge, so much fun. Thank you so much for coming on this podcast. This was delightful. Thank you.
Thanks, Sanjeev.
We-
Thank you.
We appreciate the friendship, Sanjeev.
You're welcome.